Okay, so the next group of molecules we want to discuss are called ketones. Okay, so for ketones, we want to underline the O-N-E in the word ketone. So ketones have this general form. Okay, and you're probably thinking you've never seen element capital R before. So in organic chemistry, capital R just stands for any carbon chain. Okay, so R can be any sort of long carbon chain out here. But this is the part that we focus on to recognize a ketone. Okay, so let's go ahead and dive right in and kind of learn how to naming these by doing rather than listing out names. So, there we go. Okay, so we see this structure, we recognize it as a ketone because there is a carbon double bonded to an oxygen with a carbon on either side of it. So the first step, as always, is to count the carbon chain. 1, 2, 3, 4. There are 4 carbons, so I write B-U-T. There are only single bonds, so I have A-N. And when I say only single bonds, I mean only single bonds between carbon and carbon. Okay? There is a double bond between carbon and oxygen, but for the A-N, E-N, Y-N purposes, we only care about the single, double, or triple bonds between 2 carbon atoms. Okay? So then, because I have a ketone, okay, in this molecule, or this molecule is a ketone rather, I put O-N-E, so butanone. But now, as always, I have to tell where the functional group is. So where is the oxygen double bonded to the carbon at? So I can number it 1, 2, 3, 4, or I can number it 1, 2, 3, 4. So I choose the numbering scheme that gives the functional group the lowest number, so I call this 2-butanone. Okay? The BUT tells me 4 carbons, the AN tells me carbon-carbon single bonds, and the ONE tells me it is a ketone, and the 2 tells me only second carbon. Okay? So let's look at another one. Okay? So hopefully when we see this, we recognize this as a ketone. So I'll go ahead and count the carbons, as always, 1, 2, 3, 4, 5. So I put pent. Okay. There are only single bonds present between carbon atoms here. So I put an AN. I recognize it's a ketone. So I put ONE, pentanone. So then I number it. 1, 2, 3, 4, 5. Okay. So if I numbered it the other way, it turns out this particular example doesn't really matter. It's symmetric. So no matter which way I number it, I get 3 pentanone. Okay. So hopefully I recognize this as a ketone. Okay, so I go ahead and count the carbon chain. 1, 2, 3, 4, 5, 6. So I have hex. Okay, only single bonds between carbons, so I put AN. I have the carbon double bonded to an oxygen there with a carbon on either side, so I put ONE. It's in a closed ring, so I put cyclo. Okay, then I also still have to tell where the ketone group is, where the carbon is double bonded to an oxygen. But it turns out here, if I number this, I'm automatically going to number it starting giving this group the lowest number. Okay, so if I numbered it, it would always have to be 1. So I could write 1 cyclohexanone here, but because there's no way to number it where it doesn't give it a 1, it's kind of an understood location here. So if I gave you cyclohexanone, the name, and you had to write the structure, you draw a hexagon, put this group on here, and no matter where you put it, it is a correct structure. So when you have what we call an understood position, you don't have to write that there. Okay, so let's look at a few names and try to draw the structures. So I could say 2-hexanone. Okay, so the hex tells me 6 carbons. The AN tells me carbon-carbon single bonds. The ONE tells me it's a ketone, and the 2 tells me the location of the carbon double bonded to the oxygen. We call the carbon double bonded to the oxygen a carbonyl group, by the way, but that's a little bit beyond this class. So we draw a 6 carbon chain. 1, 2, 3, 4, 5, 6. I'll just draw 2 here. 1, 2, 3, 4, 5, 6. So it doesn't matter which side you start numbering on. You can start numbering 1, 2. Put it right there. Or on the other one, start numbering 1, 2. Okay. Those two structures are equivalent. If you flip them over and twist them, they are the same thing. So either one of those are perfectly valid answers there. So that is our naming rules for basic and fairly simple ketones.